Hello, everybody. This is Mike Regan, Midwest Account Manager for NEC, representing the NEC SL1100 telephone system. And I'd like to welcome you to another one of my continuing series of pre-recorded WebEx seminars covering different aspects of the NEC SL1100 telephone system. In this little episode, we're going to spend the next several minutes talking about integrating voice over IP. And what we're going to hope to do is to show you what is needed to integrate voice over IP from both a telephony standpoint as well as from a network infrastructure standpoint. So we're going to start with it from the telephony standpoint. What it takes to integrate voice over IP on the NEC SL1100 system. And I think you'll find that it's simple, easy, and quick to integrate voice over IP on the SL1100. Here are the components required, and it starts with the voice over IP Daughterboard. Voice over IP Daughterboard is an optional card, in that it does not occupy an expansion slot in the SL1100 cabinet. It mounts directly onto the CPU. Covers a very low cost of $249 to the dealer. Right? It comes initially configured with 16 ports, and when we talk about voice over IP ports, we could be referring to ports, channels, licenses, resources, all means the same thing. Right? So we have 16 resources or 16 ports on our voice over IP Daughterboard. And it's expandable to 32 via our 16-port voice over IP expansion license. Again, carrying a relatively low cost of $119. So ultimately, you can grow our voice over IP Daughterboard to 32 resources. And off of those 32 resources, you can hang a maximum of 64 voice over IP phones. Those resources, when we're talking about voice over IP phones, are shared resources. They're dynamically allocated. As a phone requests a resource, if there's one available, the system will supply it to the phone. When does the phone require a resource? When it's placing a call, or when it's intercom calling a digital extension on the system. When a voice over IP phone talks to another voice over IP phone, it doesn't necessarily require the use of a resource. It actually does, but it does it really quickly and releases it very quickly, so it's not noticeable. That's called peer-to-peer. Okay? Then we also sell a SIP trunk license. Your first four resources on the voice over IP Daughterboard can be used for either SIP trunks or voice over IP extensions. After the first 4 SIP trunks on a system, you then need to add our SIP trunk license, and it's done in 2-channel or 2-port increments. And there's the pipe number for that. Right? So that's our voice over IP Daughterboard. From there, we have our IP terminal. We offer one flavor of IP terminal. It's a 24-button phone. It's a full duplex speakerphone. Comes with a very competitive price of $159. It's available in both black or white. Has a backlit display, backlit keypad, RJ10 headset jack on the back of the phone for plugging the headset right into the phone. Does have an optional wall mounting unit because the phone requires the use of an Ethernet cable. Ethernet cables require a little more delicate bend radius. So if you're going to mount this on the wall, we have a kind of standoff so that the bend radius for the Ethernet cord isn't that severe. Okay. We have 2 RJ45 ports on the back of the phone, one for connecting to the LAN and the other for connecting to a PC. All right, so this phone is a 10100 switch. It does require power, and you can do that with an optional AC adapter or through a power over Ethernet switch. Okay. And then lastly, the last component required for voice over IP is only required if you're going to be doing networking. So you can network up to 5 different locations together on the SL1100. And I should mention that the maximum number of ports in the network cannot exceed 256 ports. That's your combination of lines and extensions. Right? In order to do networking, each system on the network does need to be voice over IP enabled with the voice over IP Daughterboard, which we already talked about. Then it does require the SLNet license in each system. And there's the part number for it, and it comes actually, that part number is a misprint. It's 1100.092, and it comes with a cost of $199. Your dealer price is $199 for the SLNet license. And that SLNet license tells each one of these systems that they're going to be in a network. Right? And there's many vertical markets that can benefit from networking systems together. Banks, restaurants, schools, medical offices, retail outlets, so on and so forth. Right? So when you're doing networking, when you're networking systems together, the requirements are the voice over IP Daughterboard and the SLNet license in each system that's going to be on the network. So as you can see, from a component standpoint, integrating voice over IP is not that difficult when talking about the NEC SL1100 system. What becomes very important is paying attention to integrating voice over IP in the network and the requirements of the network. Okay? Because as I mentioned in the other presentations, voice over IP and the SIP protocol is only going to be as good as the network that it resides on. And this is true for no matter whose voice over IP solution you're going to install. It's only going to be as good as the network that it's going to run on. So considerations include bandwidth. The routers. Do the routers support quality of service? Okay. Service providers, internet and web can't support the demand. And this goes back to bandwidth. Firewall settings on the network can hamper voice over IP performance. Okay. And we also have down here different SIP providers and different ISP providers. So when your SIP service provider and your internet service provider are 2 different entities, you have to make sure they're going to play nice together. But of all those, the most important one is the quality of service router. Okay? And a QoS router is nothing more than a traffic cop. In this example, we have 2 systems networked together. Right, and over here, these are small networks. You have 8 CPUs or 8 computers, 4 computers and 4 voice over IP telephones. So basically, you have 8 lanes of traffic kind of merging into 2. And if you have a router without quality of service, you're going to have all these 8 lanes of traffic trying to merge into 2. And if it's uncontrolled, you're going to get what we call collisions, right? But the quality service router acts as a traffic cop and prioritizes packets. In this instance, you would want to prioritize your voice packets and allow them through before your data packets go through. All of this happens within a nanosecond. It's imperceptible to the users, but it's still very important. So network integrity is one of the key components, or is the most key component when it comes time to doing voice over IP. And you need to look at the network very carefully and very closely. With that, we came up with some requirements when doing voice over IP with the SL1100. And it starts, again, what we've been talking about. Voice quality of voice over IP depends on variables like bandwidth, network latency, quality of service initiatives, all of which are controlled through the network. and not the SL1100. Therefore, when doing voice over IP, we recommend connecting to a fully managed data network with quality of service implemented. Now, you're going to see in this next little bit, we're going to talk about must-haves and must-pass and got to have, got to do this, that, and the other, right? But I want you to think in terms of wherever you see must, think of that in terms of should, okay? Because it depends on how voice over IP is going to be implemented. For instance, if somebody is going to deploy an SL1100 system and have two remote phones, maybe one at the business owner's house and another at their vacation home, the network demand for that type of voice over IP application is a lot different than the network demand when you're deploying a 6-line system with 24 voice over IP phones on it, right? There, the bandwidth and the demand, or demand for bandwidth, is going to be higher, right? First example, maybe it's not as important to have a quality of service router on the network. Second example, where you're running 24 voice over IP telephones, yeah, you better have a quality of service router on the network. So keep that in mind when discussing voice over IP with your customers, exactly how they're going to be utilizing voice over IP application, and that'll determine, how robust their network needs to be, right? So let's just say at a scenario leaning more towards that one where we're talking about 24 voice over IP phones on the network. Well, let's look at what we require, right? One-way RTP delay must not exceed 150 milliseconds. Packet loss must not exceed 1%. Data switches must be manageable, right? No half-duplex equipment installed anywhere within the network. Make half-duplex network equipment. Routers must provide quality of service. And adequate bandwidth must be available for all of the estimated voice over IP traffic, right? So again, remember, these musts are really shoulds, and it depends on how the voice over IP application is going to be integrated as to whether or not you actually do need to have a router that provides quality of service. In that example where I showed the networking, if you're going to network locations together, then all of these must be there. If, again, like I said, if you're going to have two remote users on the system, then those musts are not as imperative. Okay? And now let's take a look at this last bullet point. Adequate bandwidth must be available for estimated voice over IP traffic. Well, how do we determine that? Well, luckily, I have a chart. Here's a chart that shows different codecs. Codec stands for compression and decompression, at different packet sizes, and the bandwidth used for each voice over IP phone call. Right? By default, on the SL1100, we're set up at the G.711 codec using a 30 millisecond packet frame size. Right? When you do that, each voice over IP call takes up 79.5 kilobits per second of bandwidth. Right? Now let's take this information and use it in more practical terms. And we have ourselves a good old-fashioned story math problem up here. All right? In our example, the customer has a DSL connection that provides 5 megabits downstream and 512 kilobits per second upstream. Right? All right, granted, this is an older example, but let's work with it. Right? When you go to your customer and say, well, you got to have adequate bandwidth, and they're liable to come back to you and say, I got plenty of bandwidth. I got 5 megabits. I got 10 megabits. I got whatever. And that's all well and good, But this 5 megabit downstream number is really not that important for voice over IP. All right? What is important is the 512 kilobits per second upstream. Because when you're making a voice over IP call, you're sending data up the stream. Right? So this is the number we need to focus on when we're looking at bandwidth. Okay? If the customer is using the default setting at G.711 at the 30 millisecond packet frame size, at that point, only 6 calls at a time can be made. Any calls over 6 will start causing the choppy speech, and it sounds like you're talking on a cell phone back in 1986. Okay? How do we make that determination? Here's the math. Okay? The upstream bandwidth allows for 512 kilobits per second. And again, it doesn't matter what the downstream is. Okay? It's the upstream bandwidth that we're looking at. The G.711 codec with the 30 millisecond packet size uses 79.5 kilobits per second. 6 times 79.5 is 477 kilobits per second. Anything above 6, you go above the threshold and you start getting kludgy performance. Now note, up here, this is a best case scenario. We're not taking into consideration any data that's being downloaded or any activity on the data network. So in reality, this 6 calls may really be 4 or 5 calls. Right? Don't push the panic button just yet, though. So in this example, what if they only have a 4-line system? At that point, only 4 phones are going to be able to be making phone calls anyway, so the bandwidth really doesn't become an issue. If they have more lines or more phones or the potential for more phones being in use simultaneously, then we got to take this into consideration. Seriously. What can we do to fix that? What can we do to rectify it? Well, one way to do it is to buy more bandwidth. And I'm sure their service provider will be more than happy to supply them with more bandwidth, provided that the end user is happy to provide the service provider with more money on their bill during the month. Increased bandwidth, increased costs. However, there's a way to adjust for bandwidth within the SL1100. Let's take this same example. If the customer would like to make more than 6 calls without purchasing more bandwidth, they could just change the system codec. Okay? So we're going to change the codec to use the G.729 codec, still at the 30 millisecond packet size. Now each call only uses 23.5 kilobits per second. This now will allow up to 21 calls to be made. And here's the math on that. 21 times 23.5 equals 493.5 kilobits per second. They're under the 512K limit. All right? But you should note what happens when you change codec or when you change the compression. It can affect the quality of speech. All right? Things can sound more tinny or softer. Possible, not always discernible by the user. So the point is we can adjust for it, but you got to set the expectation with the end user. And we can adjust for this without buying more bandwidth, but your voice quality may decrease a little bit. Some people may notice it, other people may not. But this is one way to make adjustments for bandwidth limitations when doing voice over IP. So, wrapping it up, integrating voice over IP. From a telephony standpoint on the SL1100, again, it's relatively simple. We have our voice over IP daughterboard. We have our 24-button voice over IP telephone that's available in either black or white. And then for those people who are looking to network systems together, we have the SLNet software. But more importantly, it's the network. So you have to take a look at the network infrastructure, what type of routers they have on the network, do the routers provide quality of service, and the bandwidth requirements. How many voice over IP phones are going to be on the solution? What's the potential for voice over IP phones to be in use simultaneously, and how many? How can we adjust for the bandwidth? Do they need to purchase more bandwidth, or can we just adjust the compression of the calls? So these are the things that need to be taken into consideration when doing voice over IP telephony. If you have further questions, here's our account manager map and the areas that they cover. Please feel free to get in contact with one of us. We'll be happy to discuss the application further with you. With that, I thank you. I hope you find these WebEx seminars, the pre-recorded WebEx seminars, useful for you. And feel free to drop me a line to let me know other topics you'd like to see me cover. With that, I thank you for your time and participation, and I hope you have a tremendous day. Thank you.